Okay, pardon my messy bench, but that's the way it is when you do a lot of experimenting. And so a lot of you know I like to try to use stuff that's already manufactured for making things easier. And I decided to try something the other day. I don't know how well you can see that, but this is one of the little coils from the washing machine pump motors, uh, the drain pump, and they're used on Whirlpool and a whole lot of other ones. And you take them apart, you get these two nice little coils. See, I think I got another one laying around here somewhere. Those two nice little coils already connected up. They're, of course, they're made for 120 volts, and they're connected in series. So you separate them, and I thought, well, I wonder what would happen if I used one of those as a power coil and one of them as a trigger coil, and they're what's called the Bedini circuit. And so I've got the little circuit. My circuit is slightly modified. I've got a little grain of wheat bulb, this little tiny bulb there, connected between my pot that goes to the from the trigger winding over to the base. I've got the little grain of wheat bulb in there. That way I can see how much current's going to the base. I've got the neon bulb there that you can see. And then the little green bulb you see is actually an LED that I have connected from the base to ground in place of the little diode that a lot of people put in there. The little cap is not connected to anything. It's just left over on that board from another project. And of course I got my output diode going to a battery. And of course the other side of the battery goes back to the positive over there. I had to hook a cap across the battery because this battery was totally dead when I picked it up just for experimenting, and it was lighting my neon bulb up very brightly, which would shortly burn out the transistor if I kept going. So we're going to power this up, and you can see what it does. Oh, my meter decided to go auto off. Okay, got it back on. And right now I got about 2 volts on that battery, and it was 0 when I started a little while ago trying this out. So I'm going to turn the power on and give this a little spin. And you can see the meter's already jumped up to 31 volts or so. Once the battery starts settling down, it'll drop off. But you can see the LED bulb blinking, showing the reverse voltage from the base down back to ground. So it's not burning. I don't know if you can see it or not, but the little green of wheat bulb is just barely lit up. And that's the way you want it. I don't know if you can hear this chirping. The chirping is the coils pulsing as it's coming by. I've also got a clicking noise in the bearing as it gets going faster, but I think you can hear it speeding up. If I quit talking. But it works. You can use one coil for your power winding and the other coil for your trigger winding. You don't have to wind any bipolar coils and all that stuff. Just rig it up like this. It seems to work best if you have the magnets approaching the power coil first, and then the trigger coil, of course, still picks up, and so it fires the power coil and kicks the magnets on away. And anyway, just wanted to show you that. You can see my meter is showing virtually no current draw at all, and I'm running at about 12 volts. So once it gets going, the current just drops off almost nothing, and it's charging really well. Even right now you can see it's like 27 volts, and if I was to disconnect that real quick, my neon would probably almost blow the transistor. So I'm not going to disconnect the cap because the battery can't take it yet. So I just wanted to share that with you. That's an easy way to make a Bedini, put it together, and it runs just great. Bye bye.